Welcome to School of PE podcast. I'm your host, Chris Miller, and I'm so glad that you could join me this week. We are going to discuss topics about FE, PE, and SC, and we're also going to answer questions that will help students prepare for their exams. Let's get started. Hello, everyone, and welcome back for another exciting episode of the SOPE's weekly podcast. Happy New Year to all. My name is Chris Miller, and I got a special guest with us here today, Brian Huttner. So please, let's welcome aboard. Brian, thanks for joining us.
Hi, thanks, Chris. It's great being here. I'm honored to be part of School of PE. I'm looking forward to today's episode. I guess we're going to be talking about precast concrete. At least I hope so.
That we are. You know, I was reviewing the questions earlier. I'm like, holy cow, this is going to be a lot of fun.
Yeah.
The only thing I know really about concrete is from watching the Flintstones movies back in the 90s. So this should be exciting and interesting. So our topic today is precast concrete experiences with different structures. So Brian, if you just give a little bit of background about yourself and then we'll dive into the main event.
Sure. So I'm a precast structural engineer. Graduated from Virginia Tech in 2015. Been enjoying, life outside of college ever since. Just kind of working towards my PE was a huge goal after, I graduated. And I was a student at School of PE and passed the test first try. So, that was pretty exciting. And then they reached out and here I am, doing my thing and taking part.
No, that's fantastic. We love hearing the success stories. We love hearing about our students passing and then also about their experiences, but we also love when we get to engage with them again outside of exam prep. And I think having you on for this podcast is going to be a lot of fun. I'm going to learn things that I didn't know, so I'm excited about that as well. So before we get really far, I guess I should probably ask you, what in the world is precast concrete and what the heck do you use it for?
All right. So you've heard of Legos, right?
Oh, yes.
Okay. Imagine really big Legos made out of concrete, and you've got a crane, and you put them all together, and then it makes a building. That's the simple way, the way that I describe it to all the interns, and when we're going out and getting co-ops and stuff from the colleges, and they're all like, "I know exactly what you mean now."
That was as easy as an explanation as I think I'm ever going to hear. That's pretty cool.
But if you want it a little more in depth, it goes.
Please.
A client wants a structure and it gets bid off. It could be cast in place, which is wet concrete on the site, or precast concrete, which is the type of concrete like Legos I described that gets manufactured in a plant and then shipped on a truck, delivered to the job site, and then a crane picks it up and sets it in place and either welds it, grouts it, or some other connection method. And lo and behold, you have a building.
All right, let's have a little fun with this, Brian. So, are you a sports fan?
Mildly. Don't get too modern on me. I haven't watched sports in a long time.
Okay, well let's say you're living in LA and you're the owner of the Los Angeles Lakers, and you're going to decide that you want to build a new arena, and you want to use this precast concrete, I guess, method. How in the world do you even make these precast concrete?
Well, that's a great question, because if you think about it, you can't ship, massive pieces of concrete on everyday streets. So you've got to break everything down into pieces that are manageable. And the same with a crane. You can't just pick up the entire arena and set it down. So somebody's got to go through the steps of deciding where the joints are going to be. Sometimes that's based on structural requirements. Sometimes that's based on, the configuration geometrically. And sometimes it's just the weight limit of the roads that you're going to be traveling on, or the weight limits of the crane that, the GC general contractor might be able to afford.
So I'm assuming a lot of planning is involved in this. So, but I guess what I'm trying to say is, what is the advantages or disadvantages of going this method versus starting from the ground up?
Oh, well, the biggest one is it's in a controlled environment. So if you're pouring concrete out in the field, say that you want to build this arena and you're out there in the soil, in the grass, and pouring concrete, what if it rains? Are you going to get lower concrete strengths? Or is it getting too much water in the concrete? Well, now you got to cover up your concrete. And now you're going to have a delay. And you can't put more concrete on top of, not completely cured concrete. If it doesn't have its full strength, you can't load it up. So precast concrete's different in that it's poured in a controlled environment under a roof. Sometimes some areas are even climate controlled. The temperature is monitored while it's curing in the bed. Often it'll cure for about 12 hours, which is a type 3 cement is rapid curing. So the next morning at about 4 a.m., we can pull these Lego pieces out of the forms and then take them into a finishing area where, some guys will clean them up, finish it off, make it look, pretty, as the architects like to hear. And then we'll put it out in the yard and ship. Once all the pieces are built in our plant, then we ship them off and they start putting the building together, and it is very fast.
Huh.
Very fast. While we're doing everything I just mentioned, somebody else could be doing the foundation. Somebody else could be, doing the site work. And
Oh,
then
wow.
when they're done, we show up and the building's up in a matter of sometimes weeks, depending on the size, months, of course.
Holy cow. I mean, that's
We could put
interesting.
we could put a school up in a week.
What?
Yeah.
Holy cow, that's impressive. I mean, so speed is definitely an advantage.
Yes.
Um, Also being well, let me ask you this though. So, sometimes when you think of a controlled environment, you think nothing but happy thoughts, right? It's a controlled environment, things can't go wrong, da da da. So, okay, let's say you do that, but what happens when you take what you created in a controlled environment out into the real world underneath the real world elements? I mean, how sure are you or that it's still gonna stay together?
Yeah. So first of all, nothing ever goes wrong. But to answer the question, precast concrete is pretty resilient. The thickness of the walls is usually never smaller than 8 inches. You
Oh
think
wow.
an 8 inch thick concrete wall, that's not like your drywall in your house that might be 3/4 of an inch or something. So this stuff isn't just going to get
Wow.
beat up on by the weather. Some of our shear walls get up to 18 inches thick, and that's going to be a really stiff member. It's not going anywhere, and I can promise you the rain isn't going to be penetrating it, at least in the next 100 years.
That's pretty good longevity.
Yeah,
So when you're talking these precast concrete, you're not, I mean, the foundation is not going to be a precast, right?
that's correct. The foundations are going to be poured on site. They'll be done when we show up.
Okay, that's what you
Sometimes
okay.
if the building is significantly large, they might be halfway done. Call us, hey, we're ready, get started, and then we kind of move together as a unit. If the foundations are massive and the building's really large.
Yeah, this is interesting, and it's funny how you compare it to Legos. So I was just putting together Legos over the Christmas holidays, and it got so bad that I had to go and buy sets that were for 5-year-olds for me to build it,
Oh
and I
no.
and I still had a bunch of leftover pieces, so I could only imagine what I'd be doing with these big Lego pieces.
Yeah, you don't want leftovers of these.
No, Staples Arena would have more entrances than that was originally planned for because I'd be like, "Ah, who needs that piece anyways?" Um,
Yeah.
that's interesting. So here's another question, and when I saw it when I was reading today's dialogue, I was like, "This is going to be interesting because I think someone's explained it to me before, and I think I've probably forgotten. So I'm going to learn today. You have concrete, you have cement. Are
Yes.
they the same?
They're not the same.
Explain.
So we were talking before the show. You see a cement truck.
Hmm.
We all call it a cement truck driving down the street. I can tell you right now, there is cement within the truck, but the actual product itself is concrete. Concrete is a combination of things. Most easily put would be cement, which you can think of as glue
Hmm.
or a binding agent. You've got water and you've got aggregates like sand, gravel, etc., and then a bunch of chemicals that do all kinds of fancy things. But those items together make concrete. So the cement binds to the water, which then binds to the aggregates, being sand, gravel, etc., and then makes what we know as concrete. So cement is a very one little part that most people don't even know what it looks like. It's a powder of sorts.
So not too long ago, I was out looking around at buildings. And I was talking to a buddy of mine, and I said, "Hey, so this is a concrete wall?" And he's like, "No, this is a cement wall."
I hope
So,
it's not just cement.
so I was thinking, I was like, "Well, it can't be a cement wall." He's like, "Yeah, that's what it is." So I don't. I mean, the confusion I think I have, and I think a lot of people have the confusion that they are one and the same, or not. But
Yeah,
I appreciate you explaining that. It'd be a
a lot of
pretty. Go ahead.
I was going to say a lot of people in the construction field, they know the difference between cement and concrete, but they just call it cement because that's what everybody says. It's
True.
funny in our plants, a lot of people will call it mud. Hey, we need another cubic yard of mud over here. Please don't give them actual mud. Of course, they're meaning concrete.
Yeah, if you gave just mud, that'd be a pretty weak structure, I would think.
I would think so too.
So, how long you been doing what you do?
I've been with Tyndall Corporation for just over 5 years, working on six now.
Oh wow, congratulations.
Yep.
So I'm sure you remember your first day on the job. I'm sure you remember your first project that you worked on, and maybe just not the project, but maybe the experience itself. So you want to share with us your first project experience?
You won't believe this one. It's I didn't have full responsibility of the entire project. Let me start with that. This was a massive structure. Think about a U-shaped structure that is apartment complex, and this is made out of wood, so not concrete. And maybe let's just, for sake of argument, call it about 8 stories tall.
Oh wow.
And inside of the U, you slide in a parking garage, and that parking garage was about 6 stories tall. So this is a very common configuration. That way, everything is right there where you need it. But what if somebody wants to go swimming? Well, you just put a pool on top of the parking garage. What if somebody wants to go work out? Well, they don't have to leave the structure. Just put a gym on top of the parking garage. What if somebody wants to soak up the sun in the hot tub? Throw it on top of the parking garage. And better yet, what if you want to watch a big screen movie with a bar with potted plants, make it tropical? Put that on top of the parking garage too. So this was my project, the parking garage that housed all of these things on the roof. And
What?
yeah, thankfully, yeah, it was my first project to design after training, which, was about 5 months long. And I was given the horizontal members, which are, think about beams
Okay.
for that, and the floor itself. So, my boss did the lateral analysis. How are we going to keep this thing up in an earthquake? What happens if there's a hurricane? And my coworker, he designed the vertical elements. How are the columns going to hold
Hmm.
this up? How are the shear walls going to hold everything up? And I was responsible for the beams. And I had to find a way to hold this pool up. And I'll tell you right now, the configuration that the salesman, took off originally didn't work. And my boss didn't believe me. He said, "Give me your calcs." He looked through them, check again, check again. We had to come up with a brand new configuration to fully support this pool, hot tub, and everything. It was a really large undertaking for my first project.
Yeah, I mean, that is one heck of a parking garage.
It was, and the story gets better.
Oh.
We finished the building. We've done things we've never done before to make all this work. The torsion on some of these beams that are one-sided or outrageous, really thick members.
Hmm.
And then a year or two later, I took it upon myself to take a dip in the pool. I drove out to the job site when it was all said and done. A bunch of college students were there. I was a little out of place, and I brought my swim trunks, and I did an inspection, and I swam in the pool.
Yeah, that takes new meaning to getting your feet wet.
Yeah, my feet were very wet, and the rest of me also.
That's a exciting, funny story. I mean, I'm still trying to picture this garage.
Yeah, it's hard to picture, and I didn't even get into what it looked like. It was architectural. It was one of our we call it a hybrid system. So the building holds itself up, and it looks fantastic.
Wow. So
Um,
where was this done at?
this was near LSU down in Baton Rouge.
Okay.
I used to work for the Mississippi division, and now I've since transferred to the Virginia division within Tyndall.
Yeah, that's pretty cool. That is a project you'll never forget. Maybe not, I mean, not the
No,
project, the experience itself. I mean, the good news is at least you were able to have a refreshing swim in the pool,
yep,
and it obviously didn't leak, so that's
no,
good.
and it was still standing, which is even better.
Oh yeah, no kidding, huh? So while we're talking about parking garages, how would you design a parking garage? I mean, are you going to use that precast concrete, or how are we going to tackle this?
It's funny if you go out into the world after this episode and think and look at garages. There's pretty easy ways to tell if it's precast versus cast in place. A
Hmm.
lot of them are going to be precast because of the speed, because of the schedule. And it's easy to see because you'll see joints. The Lego pieces have to
Hmm.
adjoin, and
Hmm.
there be a gap that they usually fill with caulk or another sealant. So if you go into a parking garage and see joints, it's precast.
Hmm.
You'll see cold joints often in cast in place, which are kind of just lines drawn in, kind of like a sidewalk.
Okay.
But in a precast, you'll see lots of joints with actual air that they then seal off, for waterproofing and everything. And a lot of them, my wife has now learned how to look at parking garages, and immediately she'll say, "That's a precast one, right?" And yep, sure is.
You drive around town looking at the different parking garages on a Friday night. It's a heck of a date
Yeah,
night, right?
yeah, it is. Puts the baby to sleep.
So I got a question. So we've talked about the precast being quicker, right? You'll be able to
Yes.
put up a building faster. So if we are both going to build a parking garage, identical, like the specs are identical, they're going to be spitting images of one another. And one of you were going to go the old fashioned route, and I'm going precast. So I'm assuming the precast I'm going to get up quicker.
Oh yeah.
Then, so how much of a head start would I need to give you to make it a competitive race?
In my opinion, I'd give me at least 2 months.
Holy cow.
Because you've got to think, what if I have rain delays? I have to account for that.
That's true.
What if I don't get a break? And what that means is there's quality control out on the field. We have it in our plant. What if they pour a batch of concrete and they make a little cylinder and they test it the next day and it's not strong enough? What do? Do you tear that down? Do you wait a little longer to see if it gets stronger? There's a lot of variables that would have to go into cast in place. Now, I haven't designed one myself, so this is going off of, of course, what I know from schooling, et cetera. But the quality control could really mess them up with the schedule.
So it would
If it's
not be a fair race.
no, it would not be a fair race. They might have another argument of sorts, but I'd say precast is going to be the way to go.
I'm with you. I agree. I agree with you on that. So, when you're building a structure, obviously you're probably building it because someone asked you to build it, whether it's, a government agency or maybe somebody just wants to build an arena. And they're going to come with their set of requirements. And you're going to try your best to meet and fulfill those requirements, right? But what happens, or what is the difference between saying, "Hey, these are my expectations or my requirements for you to build," versus structural restraint?
Yes, that's kind of, I don't want to say common, but it's always a common question that'll come up. An architect will come up with a beautiful design and it's going to be amazing, and this is going to be the best project on the block or even the whole city. And then I'll take a look at it and really think, I'm not sure if we can do this or if anybody can do this. We'll try our hardest, but if I need to make a beam deeper, more depth to the beam, I'm just going to have to. And often we'll work together as a team and decide, okay, so where are we going to kind of locate the beam so that it doesn't take up, a different space. We need the headroom clearance for accessibility because vans need to get in
Mhm.
for accessibility. So maybe we need to make the floors larger between levels. Um, but I will always do everything I can to make sure that I get them their vision, either the client, the architect, or whoever's involved. But there's many times where we have to come to a middle ground.
so, so this is what I'm picturing. I'm picturing being the client, right? Of, I want this building built. I got an architect here and I got an engineer here. This architect's they drew me this gorgeous rendering of what this building's gonna look like. And they're gonna come to me and they'll be like, Chris, I can't deliver this because the engineer says it's not possible. So you guys are like I picture the engineer as being more like the level head, right? The one that, is like, well, I mean, this is nice, it's beautiful looking, but it's just not feasible.
Yeah, but at the same time, you've got to be the one that's a little creative and say, I can't do exactly that, but I can make it look like it if we did this.
That's
um,
a good
which
point.
which you can do. Almost, you can make almost any look happen, whether it be changing the size of a column and making it wider instead of deeper. They might lose a little bit of their window, but
Mhm.
they still get all of the space they want for whatever activity is going to be in that area, whether it be parking or a gymnasium or something. But
That
there's
makes sense.
always a solution that's going to give me what I need and them what they want. It just
That's
might not be exactly what they come up with.
It sounds fair. So, I mean, would you say that like the engineers and architects maybe work kind of closely together? That way they're designing something that's not so out of the realm that there's going to have to be so much, I don't want to call it pushbacks, but so much adjustment made in order for it to be possible that maybe the client isn't getting exactly what maybe they envision. So is it better that these two work together?
They work extremely close. Absolutely. They're always in communication with each other. Me being the precast engineer, I'm in contact with the architect and then the overall site entire engineer. There's always an engineer that's over the entire project. That's going to be the apartments, the site, the foundation, the parking garage, all of it. So I'm in communication with that engineer. I'm in communication with the architect. They're in communication with each other more than they probably should be. There's a lot of communication there. We're all on the same team. And
Let's
and it's funny, architects nowadays, I know, especially at Virginia Tech, they take a lot of engineering courses. I think architects are getting to be to the point where they know I need a column here, or they know
right.
I probably need a deeper beam here. How deep, they might not have a clear understanding, but they know it's going to need to be deeper.
That makes sense. I mean, and so that'll help them in their rendering of making this vision happen for the client. So that makes a
Exactly.
lot of sense. So, there's a lot of different types of structures, and I'm assuming that each structure presents or poses their own challenges. So, like, let's talk about our favorite, the parking garage.
Yeah.
So, what kind of challenges do you face while you're, creating one of these?
Parking garages are very heavy. So, they're tall, often 5, 6, 7 stories. They're large, 200-300 feet long by 150 or so wide.
Oh, wow.
And it's all concrete. You don't have any wood. You might have some what we call cinder blocks or CMU, but that's essentially concrete. It's just, they're very heavy. So in an earthquake or seismic activity, we have to design for that. So the seismic requirements are all based on weight, which is unfortunate for a garage because that's all it had. So the biggest challenge is finding how am I going to distribute these forces from the floors that are now shaking in an earthquake. How
Hmm.
do I take these forces, which are large, into the walls, through the walls, into the foundation without anything going wrong? These are going to have to go through connections between each Lego piece. The Lego pieces are together. They have to be welded or something. I have to make sure that these loads can get through those connections into the walls, into the next member, into the next Lego piece, down to the earth. That's a huge challenge on some large projects. And we've got to get creative sometimes.
That's interesting. So, on the outside, a parking garage looks like something that, what, I could say, hey, on a Friday, I need a parking garage. On Monday, it's done. But it sounds like it's a lot more complicated than what meets the eye, I guess.
Yes, and the more kind of creativity that gets into it in the forefront, the client might want something really different, something that'll stand out. That gives us more challenges as well. If they want, say they want an elevator in the middle of the building instead
Mhm.
of out towards the edges, maybe that's going to give me a really hard time. It happened last year, actually.
Oh, wow.
My boss and I had to come up with kind of not a new system, but it's something newer for us to get those
Right.
forces to spread outside of that elevator and get to where they needed to go.
That's interesting. I'd like to see that. That's an interesting concept of putting an elevator in the middle.
Yeah, instead of out towards the edges like they always are.
Yeah. Yeah, exactly. Where's the elevator? Go to the edge. So, what
Yeah.
about a hotel? You're building a
Oh,
hotel. What kind of challenges are you going to run into?
a hotel is interesting because the floor needs to be absolutely level. A parking garage, if you pay really close attention, the floors are kind of U-shaped,
Oh.
and that's a natural behavior of the floor members due to the eccentricity of the reinforcement. We can get really complex later, but if you look at the floor, it's going to be upside down U-shaped or a lowercase n, just
Okay.
slightly. You can't have that in a hotel. You can't sit in your office chair
Oh,
at a
yeah.
hotel and start rolling. That's a
That's
big.
true.
You would never think of this, but that's a large challenge because a hotel must be level. Absolutely.
I mean, I guess you would think it, but I never really, I guess, thought about that. But that's true, right? Or like a bowling alley. You have an on-level bowling alley, and whoo, it's going to cause a
Yeah.
lot of gutter balls.
All
Oh,
comes back to you. You have another problem.
yeah. So I'm going to assume that maybe I'm wrong on this next structure, and that's what you're here for. So I'm assuming if you're going to build a warehouse, that should be a pretty simple structure to build.
Yeah.
Yes.
No. No. Think a warehouse. Think of this. A warehouse usually doesn't have levels. It's one big open structure, right? Usually
Right.
pretty
Right.
tall, maybe 30 feet tall, maybe 40, maybe 50. And it's just open. There's no floors in between. So when the wind pounds on these walls, it's going to want them to bend like a
That's
pencil
true.
or a ruler when you kind of squeeze on it.
Yeah.
Sometimes if the wall isn't thick enough, they really want to bend. And you've got to design these elements so that they don't do that. And think about a warehouse too. Warehouses often will house maybe some frozen goods
Hmm.
or maybe some refrigerated areas. So you're going to want to put insulation inside of your concrete, which we can easily do. But now you don't have insulation has no strength. You and I both know that. So now you've
Right.
got to account for this at the same time. So a warehouse can be tricky, very tricky.
Interesting. Before we started talking, I was like, "Oh, this is going to be easy," but then I was like, "Oh no, he's going to tell me I'm wrong." But all right, here's one that I didn't think I'd ever ask anybody: a tornado shelter.
Oh yeah. Well, I think all of us can understand that that's going to be a tough one.
Correct.
The winds up to maybe 250 miles an hour. Um, and we can handle that. Just make the walls thicker, right? Well,
Yeah.
here's the interesting thing. Oftentimes, or maybe it's a school. I did one for a school in northern Mississippi once, and of course, they wanted the walls to be insulated. So now we have that issue again. But furthermore, when you get into the FEMA codes, which I don't have memorized, but I do remember, you have to account for a projectile, like a tree trunk flying through the air and ramming into your building. There's a load that somebody maybe much smarter than myself has figured out what that force is, and I have to take it in my wall. At the same time, I have to have the tornado takes this tree into the air and puts it on my roof. I have to account for that too. And there's a lot of things in the FEMA code that you just have to make sure you're covering yourself when you're building a tornado shelter that I never knew before I designed one, of course.
That's interesting, but here's a question. So I mean, testing has to be involved, right? So meaning like you build a tornado shelter for somebody and then you're going over to hand it over, right? The deliverable's done. Well, what did you do to test to make sure it's going to meet everything that it's supposed to meet?
Well, a PE is going to stamp those calculations, and that's going to that's going to be the test, the test of trust. you know,
I mean,
you could pray for a hurricane, but I would not or a tornado, but I wouldn't recommend it.
I was gonna say there's no way for that to be a controlled environment, right?
No,
Uh,
that's
uh,
and that's where the safety factors come in. When you're designing, there's safety factors that are built into the load itself. So this tornado is spinning at 250 miles an hour, but I'm going to pretend it's at 300. There's some code that tells you what to do. And say my wall is good for 200 pounds per square foot, maybe. I'm going to design it for 250 pounds per square foot. There's a lot of safeties involved that kind of give you that, okay, maybe this is going to be okay without actually having to test
then it's just stamp it.
it.
I'd be like, hey, I'm a PE, but let me give this to another PE to stamp.
Yeah.
So, all right. So let me ask you one more structure. So Walmarts, they used to when they first started building, they were kind of just not very aesthetic looking, right? They were just more like a warehouse that they had turned into retail. So are you going to face different types of challenges because it's like maybe the size of a warehouse, but it's actually meant for retail?
Yeah, when we get into that, we start getting into a more architectural product. When you think of a warehouse, you don't think pretty.
Right.
When you think of maybe moving towards something that's more pleasing to the eye, it's something that a lot of people are going to be visiting on a daily basis. It gets into that architectural element. We could cast in brick into our concrete so it has a brick face. The challenge that comes in, I can't count on that brick for strength, so I'm taking away my thickness of the wall. And then also all these Lego pieces, we're not going to want to see, big connections with large welds. I have to hide all of these connections. There's going to be trouble in thinking, how am I going to bear this on this column without there being some big ugly connection that people are going to see, a million times a day. Those become quite challenging, hiding your connections, getting creative, making sure that it's a smooth transition throughout the whole structure. And I'd say if you're going to have an architectural building, that's what you're going to want.
So, uh, a lot of times buildings, you want them to be aesthetically pleasing, right? You want to look at a building and be like, wow, not like, oh, that's like an eyesore. So, which of the two, I guess, is more aesthetically pleasing? Precast or ground up?
Well, precast, I would have to say again.
Really?
Yeah, we can do all kinds of different finishes on these products. So you think about it, right next to each other, you put precast cast in place, they might look pretty similar. But what if we, sandblast our panels? It's going to give it some texture. What if we heavy sandblast some and light sandblast another half of this wall? Then you're going to start seeing the aggregates reveal themselves. You can use different colored aggregates. We've had red walls before. We produce red concrete walls.
Oh,
It's
wow.
wouldn't believe it. They're awesome looking. And then you sandblast it and reveal some of the black gravel beneath. So you've got this beautiful looking wall and now eventually structure that I just don't see a ground up being able to do without a controlled environment. We're able to pour these members, reinforce these members, cure these members overnight, pull them out, and finish them with either sandblasted acid etching, water blasting. You could cast in reveals that will be perfectly straight, that'll replicate lines. You
Oh,
can
wow.
cast in like a stencil. We've done floor levels at each floor of the building, a big number one for level one. You cast that into the concrete. We've casted in school emblems into the concrete.
Oh,
You
wow.
you can cast in CMU or cinder blocks into your concrete to make it look like it's cinder block. You can do anything. You know how like on the side of the road with those sound barriers, how they all have all those cool looks to them.
Yeah,
A lot of those are precast concrete. They just cast that in.
that's pretty cool. I'm getting more and more sold on this precast. So as we're coming to an end for today, we had a lot of fun talking about concrete, precast, ground up, different structures. But let's have a little bit more fun. We heard about your first experience about building that Beverly Hills style like parking garage. But there's something that's been staring at me for the last half hour as I look down on this sheet, and I'm like, all right, I'm gonna have to ask, what in the world is nine animals?
9 animals. Yeah, they're all in our house. So I had one, and then I got married. So now we have nine.
Holy cow!
So we've got a puppy. He's about 14 years old. We've got three cats. They're all about 8. We've got 4 birds, two big ones,
Jeez.
and when I say big, about yay high, and 2 small ones. And then we've got a turtle.
Oh, that's quite a collection. I mean, I've been wanting to ask. I'm like, okay, I'm going to find the right time. I'll wait till we're done. I'll throw this nine animals. But that's a lot of animals.
It makes it very interesting day to day because you've got the dog that thinks he's a cat. You've got one of the cats that thinks he's a dog, and then you've got the turtle that is kind of scarishly more aware of the world than you'd want it to be. I walk in the door and she's watching me come to my office.
Oh, that's kind of scary.
Yeah. Thankfully, she's not quite the size of my palm, so we're safe.
Not a big giant snapping turtle.
No.
Well, Brian, I've had a lot of fun talking to you about concrete and cement. Thanks for clarifying that. I now can, appreciate precast. I'd love to have you back for another episode and kind of dig deeper into some of these other topics. So, if you would love to come back, I'd love to have you back. But again, thanks for kicking off 2022 with us, and for everyone out there, wish you all a very safe and happy 2022. Stay tuned for next week, and don't be surprised if you don't see Brian pop up here again. Brian, thanks so much for joining us here today.
Thanks, Chris. I look forward to it.
Thanks.